Welcome to this explainer. Okay, today we're diving straight into what is arguably the ultimate cosmic mystery. It's a mathematical paradox that is, literally, driving the world's top astrophysicists completely nuts. I mean, imagine you're trying to measure the length of your living room, right? And you have two perfectly reliable, meticulously calibrated measuring tapes. But every single time you use them, they're off. And not just by a little bit, they're off by a massive 9%. Well, believe it or not, that is exactly what's happening right now with our measurements of the entire universe. Our cosmic rulers, they're broken.
Okay, let's dive into this. For decades, scientists have been trying to pin down one of the absolute most important numbers in all of cosmology, the speed at which the universe is expanding. And to do this, they rely on two totally independent rulers. The first one we called the grand scale ruler. This one peers deep, deep into the early universe, measuring the cosmic microwave background, or CMB. That's basically the ancient glowing light left over from just 380,000 years after the Big Bang. Physicists take a snapshot of this ancient light and use our standard cosmological model to extrapolate exactly how fast the universe should be expanding today. Now, the second ruler is the local neighborhood ruler. This one looks right in our immediate cosmic backyard. It uses Cepheid variables, which are these stars that pulse at a very specific rate linked to their true brightness, to calibrate standardized supernovae. Essentially, they act like giant cosmic lighthouses for us.
But as you'll see here, the problem is undeniably clear. These two rulers stubbornly yield totally different results. The grand scale CMB ruler gives us a speed of about 67 kilometers per second per megaparsec. But the local neighborhood ruler, it calculates that expansion at about 73. So yeah, that is a glaring gap. They're just not aligning at all.
Now, what's really interesting about this is that to the average person, a 9% difference, well, it might just sound like a simple rounding error, right? But in cosmology, where expected error margins are usually only around 1 to 2%, a 9% discrepancy is a massive, echoing chasm. We're talking about a glaring 5 sigma mathematical crisis. It essentially means that these two highly reliable rulers are pointing to two entirely different universes. This isn't just some minor statistical glitch we can brush off. This is a fundamental fracture in our understanding of reality itself.
So what does this all mean? We really have to ask ourselves, what does this 9% difference actually mean for the cosmos? Why are the stakes so incredibly high here? Well, it's because the expansion rate is the very pulse of the universe. It's the core parameter we use to calculate the age of literally everything around us. So if we get it wrong, it means everything we think we know about the timeline of the cosmos is completely skewed.
Let's walk through the profound consequences of this gap. First off, that faster local expansion rate mathematically makes the universe appear younger. But wait, that creates a massive contradiction, because it conflicts directly with the age of the oldest known ancient stars and globular clusters. It actually makes the universe seem younger than the stars inside it, which obviously reinforces this nagging feeling that something is deeply, deeply missing from our cosmic map. And hey,
Part 1. Trapped in a cosmic hole, the KBC void hypothesis.
Which brings us to a wildly mind-bending new hypothesis. What if the problem isn't our rulers at all, but rather the specific place we are standing when we use them? Enter the KBC void, also known as the local hole. You see, if you zoom out far enough, the universe looks a lot like a glowing web, with galaxies clumped into dense filaments and colossal empty voids stretching out between them. We usually just assume we're cruising along some average busy cosmic highway. But this provocative hypothesis suggests that the Milky Way is actually adrift inside a colossal, nearly empty depression roughly 2 billion light-years across. In this specific region, matter is noticeably sparser than the cosmic average, so our galactic address is literally in the cosmic middle of nowhere. Let's move on and see how this builds a physical explanation for our broken rulers. Step 1. Imagine the Milky Way exists inside this nearly empty giant transparent bubble. Step 2. Remember, gravity is the ultimate cosmic tug-of-war. Mass pulls on mass. Now, because there is almost nothing in the center of our bubble to hold us back, the incredibly dense outer walls of dark matter and galaxy clusters overwhelmingly pull us outward toward the edges. And step 3. As we're being pulled outward, our telescopes look at neighboring galaxies and measure their speed. And here's the kicker. We misinterpret this local physical pulling, this local flow, as global universal expansion. Our telescopes are definitely recording real physical movement, but they're completely misdiagnosing the cause.
Part 2. The local flow illusion, drifting to denser shores.
And this brilliantly illustrates how this massive void completely manipulates our local galactic neighborhood. I'm talking about the Laniakea supercluster, which contains a staggering 100,000 individual galaxies. Because of the gravitational tilt created by our void, our entire local group is actively drifting toward those dense outer regions at massive speeds. We're talking roughly 1,000,000 kilometers per hour. But we aren't shooting out of this void like a bullet from a gun. Instead, imagine our galaxy as a massive ship drifting slowly with a powerful, silent cosmic current. We're simply being drawn to the parts of the universe that hold more gravitational weight.
Now, while being trapped in a void might completely mess up our math, it might also be the very reason we're here to do the math in the first place. Think about it. Compare a dense galactic metropolis to our local void. Dense regions of the universe are incredibly chaotic. They're defined by frequent, violent galaxy mergers, crazy supernova outbursts, and deadly radiation from active black holes. It turns out living in the cosmic equivalent of a boring, quiet suburb is a rare luxury. Inside our local void, there's less gravitational braking. It's vastly quieter, with severely reduced cosmic catastrophes. It presents this beautiful, cautious hypothesis that being inside this peaceful, quiet bubble might have actually been a vital, foundational condition that allowed life on Earth to survive and thrive.
Part 3. A future of isolation when the universe erases its past. But this story of the void is really just a rehearsal for a much darker destiny. We have to pivot here from how the void solves our current Hubble tension to the profound, existential future of our universe. Because the expansion of the universe isn't just happening, it's accelerating. Today, we are incredibly lucky. Our observational window to the cosmos is wide open. We can catch the ancient light of the Big Bang and accurately calculate the age of the cosmos. In a few billion years, the Milky Way and Andromeda are expected to merge into one giant galaxy. But look at the long-term forecast here. In hundreds of billions or trillions of years, space will expand so rapidly that distant galaxies will slip entirely beyond our cosmological horizon. The space between us will literally stretch faster than light can travel. In that incredibly reliable grand-scale ruler, the cosmic microwave background, it's going to stretch and cool so much that it simply turns into a completely undetectable radio hum.
So the crucial point is this. Try to imagine scientists of the future arising in a new star system trillions of years from now. They'll build perfect telescopes, point them at the sky, and see absolutely nothing but dark, empty space beyond their own merged giant galaxy. They will conduct flawless, absolutely precise calculations, and those perfectly executed equations will convincingly prove to them that their lonely galaxy is the entire universe, and that it has always existed unchanging. And they will be completely, entirely wrong. Reality itself will systematically erase the truth of the universe's fiery birth from their eyes, much like the empty space around the Milky Way might be hiding the truth of the universe's expansion from us right now.
The main secret of the cosmos isn't just hidden in black holes or dark energy. It's that the universe never reveals itself in full. It only shows you what can be glimpsed from your specific, tiny point in the unthinkably vast cosmic web. We are so used to blindly trusting our eyes and our telescopes, but the cosmos is a master of illusions. Sometimes a void is not the absence of a story. Sometimes a void is the story. If the invisible emptiness around the Milky Way can so thoroughly distort how we measure reality right now, what other traps are currently hiding in our universe?